All right, number 6, there was a mistake on number 6. So the problem should have read, Hayden ate 75 hundredths of cheesecake, and John ate 20% of the cheesecake. So we want to know what percent of the cheesecake was eaten. Okay, so there was a mistake, so just fix that. We also want to know what percent of the cake was not eaten. Okay, so first let's look at our first question. It says, what percent is eaten? So I'm going to look and see that I have 75 hundredths was eaten, and then I also have 25% was eaten. Now my answer is going to be in a percent. So before I can do anything, I need to convert this decimal to a percent. Remember, when we go from decimal to percent, move my decimal to the right, use the Dr. Pepper method. I'm going to move it 2 places. So I'm going to count 1, 2, and then I'm going to add my percent sign. So I have 75% and 20% was eaten. If I want to know the total percent that was eaten, I need to add those numbers up. So 75 plus 20, and we get 95%. So 95% of the cake was eaten. If I want to know what percent was not eaten, I need to subtract 100, take away 95, to get what was left over. So 5% was not eaten. Remember, percent means out of 100, and that is why I subtracted 95 from 100. Okay? Number 7, circle the value that is not equivalent to the others. Make sure you show all work. Remember, equivalent means equal to, so I want to know which ones are not equivalent to the others, not equal to the others. So I see that I have decimals and I have fractions. Fractions are hard to compare because remember, the only way we can compare fractions is if they have a common denominator. Okay, so instead of trying to find a common denominator for 5 different numbers, I'm just going to use decimals. Okay, so I need to convert 8/5 to a decimal. Okay, remember, if I have a fraction, I'm going to divide. So this means 8 divided by 5. Use your horse and rider method to help you set your problem up. 5 goes into 8 one time. Subtract. 8 take away 5 is 3. Bring down my 0. 5 goes into 30 6 times. 6 times 5 is 30. And I just have 0 left over. So 8/5 is equivalent to 1 6/10. Okay, now let's check 1/6. 1/6, I'm going to do the same thing, convert it to a decimal, so I need to divide. Remember, the rider goes inside the house, the horse goes outside. Set up the rest of my problem. 6 divided by 1 is just 0. 6 does not go into 1. 6 goes into 10 one time. 6 times 1 is 6. Subtract, I have 4 left over. Bring down my 0. 6 goes into 40.
Okay, so 6 into 40 would be 6 times. 6 times 6 is 36. You get 4 left over. You can't stop yet. You have something left over and you have not seen a clear pattern. So you can add another 0, bring it down. 6 into 40, 6 times, which is 36. Now you should be able to see there's a pattern. So 1/6 is equivalent to 16 hundredths repeating. So I'm going to give myself some more room here. Erase some of our division. Alright, so then you needed to convert 16 over 10, excuse me. So you're going to 16 divided by 10. Does 10 go into 16? One time. Bring down your 0. 10 into 60 would be 6. 6 times 10 is 60. And you have nothing left over, so you could keep going, but you can see that 16 over 10 is 1 6/10, and then 1 3/5. So with this, we know we're going to have a whole number. 3/5 is what we would divide, and that's one that we have memorized. It's a benchmark fraction, and it is 6/10 or 60/100. So you can see after you converted all of them that the only one that is not equivalent is 1/6. You need to convert the following percents into decimals, and we discussed this. We have 68%, and we talked in the beginning about it being a base 10 system, and you're multiplying and dividing by those base 10. And we also said the shortcut was Dr. Pepper. So if this is a percent, we need to move 2 times to the left. And what are we moving? The decimal. So we have 68%. I don't see a decimal, which means it's hiding at the end. Cross it off to the left, to the left. We ended up with 68/100. Same concept, you're going to move it 2 times to the left. You're going to move the decimal 2 times to the left, but you already see the decimal right here. So you find it, cross it off, move it 2 times, and you'll get 743 thousandths as your answer. Number 9, explain what this decimal means, and that is 54/100 repeating. So first of all, I would explain that it is repeating. Okay? A repeating decimal means that it is actually going to keep going. Like this 4 is what's going. As opposed to, let's say I just had the number 54/100 without the repeating sign, and I wanted to compare these, I would add a 0 at the end as placeholders. So that is the difference with how it would affect it. Because 54/100 repeating means that you keep adding 4s instead of 0s, which would make this number greater than this number. So like for example, if I had 2/10 and I had 2/10 repeating, okay, well 2/10, if I wanted to compare, they could put a 0 here, and this 2/10 repeating, I'd have to put a 2 here, so automatically this is greater. So that's what it means and how it would affect how you compare. Number 10, fractions into decimals and percents. The biggest thing for you to remember here is there are 3 strategies to convert fractions to decimals and percents. The first thing you ask yourself is it a benchmark fraction? 1/8, is it one that we have memorized? Probably not. So then I want to divide, or my next strategy would be, can I make it out of 100? None of these I can. So then my next strategy would be, okay, I'm going to divide them. So 1 divided by 8. It's that horse and rider that we talked about. And remember, horse and rider is not what we're doing. It's just a little picture that helps us remember which one goes in the house and which one goes outside of the house. So when you divide this one, you would get 125 thousandths. Let me show you really quick. We'll do 1, gives me 8, 2, bring down my 0, 8 into 20, 2 times, 16. And this is the part where some of us go, okay, I'm going to take the 4 that's left over and bring it up to the top. That is not correct. You have to add another 0 and do the process. So 8 into 40 would be 5. That's how I got my answer. And then move our decimal 2 times, which is 12.5%. So 125 thousandths, 12.5%. Let me give myself some more room here. Okay, so we look at 5/9. That is 5 divided by 9. Because we already said it's not one we have memorized and none of them we can make out of 100. So then we have to do the division. 9 goes into 50 5 times. That should be a 4, sorry. So 50 minus 45 is 5. 9 goes into 50 5 times, which would make this 45. And I see that a pattern is happening. If I wanted to keep going, I would see it. So this answer is 55 hundredths repeating. And then if we wanted to move our decimal to get the percent, we'd move it 2 times, 55%. You could also say 55.5%. Which is the more accurate answer. So 55.5%, a little repeating symbol. All right, so make some more room. 4 elevenths is another one. You need to divide. 4 divided by 11. That's not a decimal. Let's erase that. So 11 does not go into 4. Does it go into 40? Yes, 3 times, which would give us 33. All right, so 11 into 70, 6 times to give us 66. You get 4 left over. I'm going to add another 0 because I haven't seen any patterns just yet. And I have leftover, so I have to keep going. So 11 into 40, 3 times. Oops, excuse me, that's messy. 40 minus 33, 7. Still, oh, okay, so I see that there's a pattern going on here. This is going to repeat itself. This would end up being a 6. So what I would put would be 36 hundredths, and both of them repeat. So they need to have that repeating symbol. And then if you were to move your decimal, so you have 36 hundredths repeating, you move it 2 times, it would be 36 hundredths repeating. If you rounded it, you would get 36 4/10%, so either one is fine. And number 11 says, write a math statement with negative numbers that shows greater than, less than, or equal to. And we gave you an example. -1 is greater than -8. So this answer, you can have lots and lots and lots of different choices. But I'll just give you a couple more examples. The biggest thing is that we wanted you to use a negative number and tell me greater than or less than. So -2 is greater than -5. -11 is less than -3. Remember, use that number line. If you're moving to the left on the number line, you are getting less value. So that's kind of how we did this here. Number 12, ascending means going up. Okay, if you think about that as an order, if numbers are ascending, they are going least to greatest. If you're descending, you're going down. So if you think in numbers, if you order them descending, that would be the greatest number to the least number. Percent is out of 100. And equivalent is equal. Good luck on your test tomorrow.